All right, this is a quick review video of constructing the circumcenter and the circumcircle of a triangle. Okay, so in this case, we constructed the circumcenter of an obtuse triangle. Okay, and because it was obtuse, our circumcenter is outside of the triangle. Okay, so remember we use our perpendicular bisectors. This perpendicular bisector of the line segment SAM Alex represents all of those points that are equidistant from SAM and from Alex. Okay, this perpendicular bisector between Tony and Sam represents all of the points equidistant between Tony and Sam. And this perpendicular bisector between Tony and Alex represents all of the points equidistant to Tony and Alex. Okay, all of the amazing thing about the circumcenter is that all three perpendicular bisectors will always intersect at a single point. And that point is equidistant from Tony, Sam, and Alex, or in the case of any triangle, it will be equidistant to all three vertices. And we can use that circumcenter to draw a circumcircle that will pass through all three vertices. Pretty awesome, pretty cool. And let's call this triangle A, B, C. Okay, and in order to find the circumcenter, notice that all three of these angles are acute. So we know the circumcenter is going to lie somewhere inside the circle. And I'm going to use my compass to find the perpendicular bisectors of each side of this triangle. So let's start with AC. Okay, so I want to set my compass. This is too small, right? It's got to be over halfway. I like to go for about 2/3. It works out nice. And I'm going to draw an arc, right, from point A, keeping my radius the same. I'm going to draw the same arc except from point C. Okay, you don't have to draw the whole arc. You can just draw the parts of it that are important, but I like to draw the whole arc. I call that my fish. Okay, then I take these two intersections, and if I draw a line through them, that is going to be my perpendicular bisector, right? Perpendicular because it's at 90 degrees. Bisector because these 2 points, or these 2 segments are going to be equal, right? And of course, my midpoint of AC is going to be right here at the intersection of the perpendicular bisector. Okay, now I already know that my circumcenter is going to be somewhere on this perpendicular bisector, and we can find out exactly where by finding the perpendicular bisectors of either of my other sides. Let's go ahead and find the perpendicular bisector of AB. So I can use this same measurement for this one. I'm going to go to B and make my fish. Let's carefully draw this perpendicular bisector. Okay, and again, notice it's perpendicular. Notice that this segment and this segment are equal. In other words, this is the midpoint of AB. Okay, but we're not interested in the midpoint this time. We're interested in this intersection of the two perpendicular bisectors. That point right there is our circumcenter. All right, now we can check our answer, but before we do that, I always like to find the third perpendicular bisector. It's easy, it's quick, and we can make sure that we haven't made any mistakes. Okay. So let me color in these 3 lines so we can see. And they all meet in one single point which we call the circumcenter. And we can use that circumcenter to draw our circumcircle. Just make sure you set the radius to the distance from the circumcenter to one of your vertices. You can see that the circumcircle, right, is the circumcircle goes through each of my points A, B, and C. And that's our beautiful construction of a circumcircle.
So for tomorrow, I want you to construct a right triangle. You can make it any size you would like. Make your right angle using your grid paper. And then I want you to find the perpendicular bisectors, all three of them, so that you can find that point of concurrency we call the circumcenter, and use that to draw your circumcircle around the right triangle. And come ready to answer the question, is the circumcenter inside the triangle or outside the triangle? Okay, have fun and enjoy using your compass in 2020 fun. See you guys tomorrow.